Back to my topic, everybody knows, or many people know, about foreign data wrappers, FDW. It's a technology that provides access to external sources of data in the form of a Postgres table. One of the goals was to get access to API. I started looking for it and to make sure there is a FDW available, because there are a lot of them in the community, but all I could find did not work with API. It worked with the file. You need to download the file offline, and you will not get all the data but a limited area, which is not good. You can certainly develop your own foreign data wrapper as any permission. In Postgres, it is done on C++, but the task did not worth developing it on our own. I've heard that there is multi-core technology which allows to write FDW on Python, which is simpler and faster. So please follow the link to read the documentation with examples. There is a report on one of the conferences, z2d2. You can read about this technology. I've never developed on Python, but I found an example in multi-core, and I redid it for my purposes. So the full code fits into one screen, which, of course, is very compact and elegant. So how does multi-core work? From the technology point of view, this is one FDW, but different servers interact with a specific code on wrapper. You further do create server and work with a script. In this case, I had OSM of DY is my script, and it works with 3 different functions. After you create servers, we create external tables and indicate the appropriate server. In this case, OpenStreetMap has 2 types of objects, a line and a dot. So all knowledge is lines. Dots can be inside the lines or outside the lines, and for them I created different tables. This is an example of a query for the identifier. Just to make it more interesting, let's have a look at real data. For example, this is the city of St. Petersburg, Rubinstein Street. Let's pick a dot, a point. Let's say it's a fast food restaurant. Let's pick a location, identify it, and then perform a query. This is what I do. This is my external table. I apply to my external table. And download data, get the coordinates of this location and the tags, including all information which can be visualized, and it is contained in tags. It was a location, a dot. Let's take a line. Let's pick a building. You can see the tags, and we'll get hold it in Postgres. We should write where and change the identifier with the appropriate one. And again, we have data downloaded in the form of Postgres table tags and location identifiers, which are included in this line. Everything is good, everything works. The next example is the same tags in the form of hstore, in the form of a table. So I've prepared a query so that I don't type in front of you. So let's do the same. Let's do it for the same object. Take our identifier and get hold of tags in the form of a table. The same through our external table of OSM test way, which interacts with the external API. Things look good so far. Let's see how multicore is organized and how does it operate with where, with input parameters. In execute function, we have quals parameter, and these are our OVR conditions. This quals is an array. It is viewed, and there might be several conditions of where, but in our case we have one. It has a field. Wall has a field. ID is the name of the field. Operator equals, and here is the value of our identifier. In my function, I have this log report here. If we check the report, we can see the ID and the endpoint API to which my wrapper calls upon. Let's complicate the query. Let's take several points. Let's say select an in operator and see what we get in the report, in the message. What do we get in our multicore as a parameter? We see that this is the design. It is transformed into an array. In the value field, we have the Python array. This is not a text, this is array. It is called class list, and we work with it. In multicore, in our code, we can select different cases if it's a scale value or depending of whether it's a scale value or an array value. That was a request to in operator. We can write our own array and we'll get the same. The Postgres optimizer will bring it to the same view. So with array, this query works as this. Let's do join with the table. Imagine we have tables with our identifiers of points. We want to do join with our external table. We simulate the table with select and union select and do join and see what comes to multicore. Empty squares, nothing comes. This puzzled me and I started looking for the answer. Is it possible to support multicore with join? I found the examples like this. If your foreign data wrapper on multicore works well, but with some restriction, with some limited amount of data, for instance, it can read objects from file, and in that file we have 10,000 objects. You may get all those 10,000 back. If you do this join, this wrapper will return all those 10,000 objects to you, and Postgres does join and falls and throws away the unnecessary one. This is not an elegant solution, but it is a viable solution. In REST API, it is not applicable. We cannot get all the data of OpenStateMap. There are too many of them. That's why we can do nothing here. We cannot do the join. Because, as I showed in the previous slides, multicore worked with the array. I tried to aggregate the table into an array and performed a query which worked for the array, which was in the text of the query. But for the aggregated array, things didn't work. So we get those square parentheses. Maybe Postgres optimizer changed this aggregation to join and didn't do it. It's hard to say. Or maybe we can write join later, but it doesn't work. Nothing comes to multicore. Then I took a table with an array and I didn't aggregate anything. I took the available array and tried to use any operator where ID condition. Again, nothing comes to multicore. Why does it work for the array which is given in the text of the query and it doesn't work for in this case? If we have a look at the query plans, they might help us, but let the multicore developers deal with it if they want to improve their tool. We have what we have so far. Join cannot be performed in any fashion. However, I found one case when join was possible. When you join in the table, there is only one line, it is possible. So the condition comes in this form, ID equals, and then the scale value. You may be happy that this is working, but on the other hand, I don't like this solution where it works with one line, but it doesn't work with more than one line or one string. So it is string number dependable. This is like shooting yourself in the leg, especially if you have a new developer who comes and doesn't know all the subtleties and starts changing the number of strings and things stop working. Let's have a look at an alternative, not multicorn FDW, but Python. PL Python. I took the same code that I had in multicorn wrapper, copied it, and it worked. These are two similar queries, one via multicorn and the other performed via PL Python. I'll show you that it works. The same object. Let's take the same one.
То есть теперь уже да, не мультикорн, а вызвали функцию и
Not multicorn, but we called a function and the same data arrived. Things work well.
И теперь, собственно, то, что у меня никак не получалось
And now this is what I couldn't do with multicorn FDW. If in the table we have several identifier values, I wanted to join them and get hold of data from OpenStreetMap. This query works here. In this very case, we call the function getNode. Per identifier will be called upon for each string. The same query for multicorn FDW doesn't work. Nothing comes to the condition, to the ID. If we don't want to call the function several times, we can do it differently. Aggregate a table into an array and write a function which assumes array as an argument. This is a workable solution. So the practical task for which I did all this, to get data of the line from OpenStreetMap and identifiers of the line, and then get hold of its data, coordinates, and tags. Let's take a live example.
Возьмем, допустим, тот же самый объект.
Let's take the same object. This is the query text.
Ставим наш идентификатор, который мы с OpenStreetMap.
This is the identifier taken from the OpenStreetMap. The query is performed for quite a long time, and I will explain why it is so long. So here we get all the data of the point, and all points have coordinates, and some even have tags. Let's check the messages. Via API, we receive data of the line and data of each point. For each point, we have to do a separate API call, which is not a very beautiful solution, but for some cases, it might be good. When foreign data wrapper operates with files, we have to call upon it to get data from each file. So it would be a good option. Or there is another option. If we don't want to call the function every time, we give the array and use the function that accepts the array. In OpenStreetMap API, there is no endpoint that would accept the array. I have implemented it, but inside, in the cycle,
Так. Теперь теперь все-таки у Multicorn FDW есть небольшое преимущество, в отличие от PL Python. Он
FDW
поддерживает
has
тип
an
HStore.
advantage.
То есть в данном случае
It
информация о
supports
тегах,
HStore type.
колонку для
Information
тегов
from
я
tags,
сделал в
tag
виде
column
типа HStore.
is in the form of
И в
HStore.
Multicorn мы
And in
просто
Multicorn,
можем использовать ассоциативный
we
контейнер
can
Python, который
use
автоматически будет преобразован в
associated
HStore. То
container
есть
of
Multicorn
Python
это
to
умеет
be
делать сам.
converted
PL Python
like
этого
this.
делать не умеет,
Multicorn knows
поэтому
how to do this.
нам
PL
приходится
Python
формировать
can't
HStore
do
в
it.
виде
So
строки,
we have to
что
form
немножко усложняет
HStore
текст.
in the form of a string,
Но,
which
кстати сказать,
complicates the text.
тип JSON-B, который
But
основан на том же самом
JSON-B,
языке, что HStore,
based
поддерживается
on the
и там, и
same
там. Поэтому
engine,
можно
is
использовать
supported in both
JSON-B,
cases. You can use
который более
JSON-B,
новый, более совершенный. Но
which
все-таки
is more
иногда, мне кажется,
recent, more
удобнее бывает использовать HStore.
perfect. But
Но если
sometimes it's better
данные,
to use
например,
HStore,
совершенно
especially
точно знаете,
if
что одноуровневые, только
data
строковые,
are
тогда
single
HStore, мне
tier,
кажется, лучше
then
отражает
HStore
структуру. Вы точно понимаете,
reflects
что
the
это такое.
structure better.
Вот в этом
You
случае
better
Multicorn
understand what
немножко
you are
удобнее.
dealing with. So
Теперь
Multicorn is
еще
better
одна
in this
функция
case.
API
One
OpenStreetMap.
more
Все-таки есть
function
функция,
of
которая
API
позволяет
OpenStreetMap. There is a function
за один вызов, за одно обращение
that
к endpoint получить
helps you
данные по
get
сразу по группе
hold
объектов,
of data on
но
a group
вам
of
нужно
objects
передавать
with
области
one
из
call,
координат.
but you need to
Вот.
provide
Я тоже сделал
areas
внешнюю
from
таблицу
coordinates.
для
I
начала
created an
на Multicorn
external table
скрипте.
on
И, соответственно,
Multicorn
вот у
in
меня
my
параметр
script.
bbox — это
These are the
массив, в котором мы
parameters
передаем
bbox.
4
This is the
координаты. Ну, в
array
принципе, с тем
with
же
4
успехом можно было
coordinates.
сделать 4
You could
разных
have done
колонки
it with 4
и опять же
different
4
columns
координата, которые
for the same
ограничивают
4
нашу область
coordinates,
на карте.
which limit our
И
area on the
опять же
map.
я сделал два варианта, то есть один
So I've created two
через
options,
foreign
one
data wrapper Multicorn
through
и
foreign
другой
data
через
wrapper
функцию.
multicorn
Ну, в
and
данном
the other
случае
through a
код
function.
SQL
In our
скрипт через
case,
функцию даже
it is
немножко более
SQL
компактно
script.
выглядит.
SQL
И
script
давайте
looks
тоже
more
на реальных
compact
данных
and
это все
concise.
выполним.
Let's perform this on real data.
Скрипт. И возьмем, опять же, с точки на карте, вот прям
We'll take a
возьмем
point on the map.
вот эти координаты настоящие.
Let's take the actual coordinates.
Здесь только у нас широта с долготой менее местами, то есть у меня
The
это
latitude
как в
and
endpoint. И здесь нам взять,
longitude are
соответственно, немножко больше области.
have changed places, but it doesn't really matter.
9. Давайте попробуем. Вот, запрос выполнился довольно быстро.
So we
Нам
performed
пришло
a
ровно
query,
1000 строк. То есть, видите, это
and we
все
received
точки, которые попали в
1,000
эту область.
strings. So
Соответственно, по
all
ним
points that got
также
into
все
that
данные,
area, we
все
received data on
координаты.
all those points. We receive all the
И давайте
coordinates.
сравним альтернативный вариант. То же
Let's
самое на
compare an
PL Python.
alternative option. The same on PL Python.
Был как называется? Get notice просто называется. И те же самые. Смотрим. Да, та же 1000 строк пришла.
So we get the same 1,000 strings, the same data, but if we compare this, you may see a slight difference. In Multicorn, we have a column, what we send to where. When we create where, we create a column, and it appears in the output. And because there might be a lot of strings in the output, there might be some excessive data joining those strings. But we need to fill this out, otherwise you will not receive those strings. This is how Multicorn operates. Of course, in select we may not indicate those strings and indicate only what we need. But in this case, in Python, we don't need to receive these data. And I decided to compare the performance. I took a slightly bigger area on the map with over 30,000 lines. I called upon them several times, and these are the milliseconds for PL Python and Multicorn. We see that PL Python is slightly faster, and we see a distribution. I then understood that I didn't measure accurately because these measurements include receipt of data, because it takes the server to form the data, about 8 megabytes that we attract. So for the test, I took the file, saved it, and posted it on this local server where the Postgres is deployed. Then download was immediate, and the data became more representative. I made several measurements, and we see that it has become 4 times faster because we don't take a big file from the internet, and PL Python is better by 30%.
And we can assess performance this way. We receive this code, we receive the data as XML file, and after that, the code returns the data in the form of Postgres strings, and performance is about 30,000 strings per second. And if this is not a high load system, I think that this is quite effective. Another advantage of multi-core foreign data wrapper is that from this outer table you can not only read data, but also introduce changes, execute insert and update operations if you need it. Because in this case, this is read-only source. But there can be various cases. That's why when you need to have insert and update, probably it will be more convenient to use multi-core foreign data wrapper. Of course, SQL language is also supported by Postgres. The operators insert, update, and join data wrappers as well as selector will not function with it. But changing the data string by string, entry by entry, in many cases this will be available and like select operations. So, if we compare foreign data wrappers that allow us to use the flexibility of SQL functionality, then of course it's more convenient to use SQL. Because when we use storage, we can get some limitations. But this is not about multi-core FDW, because of course we can write SQL, but as I said, these joins never work. And on PL Python, we have more opportunities. We use more difficult, more complicated constructors, such as join lateral. The syntaxes gets more complicated, but we get a working solution that we didn't manage to get on multi-core. And the process of writing code on PL Python is simpler, because on multi-core you need to deploy script, create a server and an outer table, and in case of upgrading, it's necessary to drop the table, the server, recreate the server and the outer table. But thanks to this function, you will have only one operator, outer function, and that's it. Speaking about performance, PL Python was a bit faster, not 3 times faster, but still it is 30% faster. And the last 2 points, these are the advantages of foreign data wrapper. They support insert and update. Of course, you can use functions for it, but you will have to write different functions for receiving the data and updating them. But thanks to multi-core, you can do it with one outer table, and multi-core supports each store directly. PL Python doesn't do it. JSON-B is supported by both. So, in conclusion, I would like to tell you about the way I decided to choose this topic. Well, I was looking for FDI, and I realized that it was not reasonable to write it on C, but I've heard that you can do it on Python, so I found multi-Python. It was much simpler compared with C, but it turned out that using PL Python, it can be even simpler. So my message is that if you've heard about multi-core, that it's possible to develop wrapper on Python, before starting writing it, probably at first you should compare it with PL Python and decide what's more suitable for you. And this was an R&D. I haven't used neither multi-core FDW nor PL Python in my real projects, but I used another alternative language. This is PLV8, and I have a major framework that allows me to fulfill complete cycle of development with debugging and automatic deploying and many other things. Now I'm gathering information and I will speak about this topic on future conferences. I think it's really interesting and I hope that the organizers think so too. And you will be able to see this presentation in the future. That's it for me. Thank you. I would like to thank Alexei for his interesting presentation. And I would like to remind our participants that if you want to ask some questions of the speaker, you can ask your questions on the chat. And I would like to make the following question. Have you tried to make wider benchmarks and use them on long and short queries, and what results have you received? Of course, the results can be different on different number of entries. I haven't tried large benchmarks. The reason is that the use of foreign data wrapper is limited by other factors. If FDW was faster than PL-Python, probably in that case, I would think what is more needed for me, this performance or the opportunity to make a join. But in this case, PL-Python was better in both cases, so I did not have this need. It hasn't reached production yet, and if it does reach production before selecting something, I guess that I will fulfill benchmarking testing in a more meticulous manner. Okay, have you tried using just-in-time compilator for PL-Python? No, I haven't. Thank you for the idea. Will we have other questions on the chat? In that case, I would like to invite all our participants to a special chat. There you can talk to speakers, discuss everything. It will not be on air. These are talks behind the scenes in online, and I can add that on these slides. You can see my contact data, you can write me, or you can download the script for FDW and you can try launching it. So, I guess that we can conclude our Q&A session. I would like to thank the speaker for the interesting presentation. And now I would like to remind you that every participant can organize their meetup. There is a link, or for a topic for discussion, you can fill in the form, and we will be able to discuss everything. And now we will have a break. We will restart at 10:40.